Good morning. Myself Prabha Ranjay, working as a assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the topic realization structures for IIR filter from Unit 2, that is IIR filter design. Okay, let me discuss. The realization of an infinite impulse response filter refers to the implementation of the filter in hardware or software. IIR filter are a type of digital filter used in signal processing with characteristics such as feedback loops, which can cause instability if not properly implemented. Yeah, already we have discussed, transfer function of the filter h of z equal to y of z divided by x of z, which means y of z means output response of the filter and input of the filter x of z. Similarly, frequency response h of omega equal to y of omega divided by x of omega. The difference equation is an efficient way to implement discrete time systems. The convolution of input sequence x of n and unit sample response h of n gives the output y of n. And we know what is FIR systems and IAR systems. Once again, I tell you, unit sample response or impulse response H often has a finite number of terms. This is called FIR systems. IAR system means length of unit sample response or impulse response is infinite. And also, you know about the what is recursive system. Already we discussed what is recursive system and non-recursive system. Once again I tell you, the recursive system output y of n depends on present and past input as well as past output, and this is called recursive system. The non-recursive system means the output y of n depends on present and past input. Actually, the realization structures for IIR filter is classified into four types, which means direct form 1. First one is direct form 1, direct form 2, the cascade, and parallel form. Okay. Yeah, direct form 1, the filter is implemented using the difference equation directly. It is the most straightforward implementation, but can be numerically unstable for certain filter coefficient. And direct form 2, this method rearranges the direct form 1 structure to reduce numerical sensitivity. It may require fewer operations than direct form 1, leading to potentially faster implementation. Cascade form. The filter is decomposed into second order sections, making it easier to analyze and implement. This form can offer improved numerical stability and precision. And final one is parallel form. The filter is decomposed into parallel branches, each processing a portion of the input signal. This can be useful for parallel hardware implementation. Okay. Some elementary blocks of realization structures, that is, you can see adder circuit and constant multiplier circuit and unit delay circuit and signal multiplier circuit, advancing element, and multiplication. This is the elementary blocks of the realization structures for IAR filter. Okay. Uh, Here, first we have discussed direct form 1. In this video we have discussed direct form 1. The general equation. First, in the direct form 1 realization of an infinite impulse response filter, the filter is implemented directly according to its difference equation. The difference equation of an IIR filter describe how the output y of n depends on the current input sample x of n and previous output and input samples. The general form of the difference equation of a second order IIR filter is y of n equal y of n equal b naught into x of n plus b1 into x of n minus 1 plus b2 into x of n minus 2 minus a1 into y of n minus 1 minus a2 into y of n minus 1, where x of n is the input signal at time index n, y of n is the output signal at time index n, and b0, b1, b2 are the numerator coefficient, a1, a2 are the denominator coefficient. The direct form 1 realization directly implement this difference equation using delay elements to store past input and output samples and adders and multipliers to perform the necessary arithmetic operations. Here, a simplified block diagram of the direct form 1 realization for a second order equation. In this diagram, x of n, x of n minus 1 and x of n minus 2 are the current and past input samples stored in delay element. Y of n, y of n minus 1 are the current and past output samples stored in delay elements. B0, B1, B2 and A1, A2 are the filter coefficient. The multiplier minus B1, B2, A minus A1 minus A2 multiply the delay input and output samples by their respective coefficient. The adders sum the product to produce the output sample y of n. This structures directly follows the difference equation and is relatively simple to implement. However, it may suffer from numerical stability issues, especially if the filter coefficient result in high gain or sharp resonance. This is the general diagram for the direct form 1 realization. If you have any doubt, you can comment me. We will meet in next video. Thank you.